Okay, let's see. We are going to do 8.2 today. Teeny weeny little section, 5 problems. It's the way I promised you we'd go out. 8.3 on Monday will be similarly very tiny, and then we'll review, and then we'll review, and then we'll review, and you'll take your final. I know nothing more about what the fall will look like. We did get guidance on final exams, and this fits within final exams. They asked us to do a 24 to 48 hour window, and this is 60-hour window. So our final is the way I thought it would go, and we're ready to go on that. Okay, let's look at 8.2. 8.2 is called Arithmetic Sequences. It means you're adding numbers up. You're adding a number, you've got a sequence, and in each case you've added a number to the previous number. So let's just start right in. They're going to ask you to write the first 6 terms with the first term being called a sub 1 and with a common difference, messed that up, common difference called D. So the problem will look like a sub 1 equals 300, D equals 60, something like that. That's the information you'll be given, and you're asked to write the first 6 terms. So this is the first term. We've got a sub 1 equals 300. And then what we're going to do to every subsequent one is add an additional 60. So a sub 2 will be 300 plus 1 times 60, which will give us 360. A sub 3 will be this 300 plus 2 times 60. We'll throw in, instead of 160, we'll throw in another 60. So this is 120. 300 plus 120 will give us 420. A sub 4, just meaning that the fourth term in this sequence will start the same way. We'll have 300 as the initial, that's the first term, a sub 1, plus 3 times those 60s. So we're just adding in a 60 here. And I know we could just add 60 each time, that'd be the easy peasy way, but we're looking for a general formula for an arithmetic sequence, so we're looking for patterns here. A sub 5, start with that first one, that a sub 1, and then we're going to add, in this case, 4 times 60. So it's just 60 more than this one. This will be 540. And then a sub 6, again, start with our initial number, our first term, and then we're going to add in one more 60. So we get 600 there. Okay, so these are the answers, 300, 360, etc., through 600. But I want us to look at what we've been doing to develop a general formula for arithmetic sequences. I'm hoping that you're seeing that a sub n, any one of these, would be equal to a sub 1. We started with that one. Then we're adding, and here's the trickiest part. When we were looking for a sub 2, we added 160 in. When we were looking for a sub 3, we're adding 2 60s in. So you can see that this number is 1 less than the term number. So we're going to be adding in an n minus 1 times d. And that's the magic formula right there. We start with what we start with, and then we're going to take 1 away from the term number. If we're looking for the second term, we'll take 1 away from 2 and get 1 times 60. etc., all the way down to 5 times 60, or a billion times 60. Take one away from it, and then add in the a sub 1, the initial term. Okay, let's do that again. Let's say that you're given a sub 1 is 390, and the difference is a negative 110. So we'll actually be subtracting this time instead of adding, because it has a negative in front of it. So a sub 1 is 390, and we're looking again for the first 6 terms. A sub 2, all you need to do is subtract 110 from that, get 280, and you're on your way. But we're developing this idea here. So we start with 390, and then we're going to add in 1 times the negative 110. 1 times negative 110. So it is 390 minus 110, which is 280. The third term we've got, start with 390 again, and then we want to throw in 2 negative 110s. And so we're just subtracting another 110 from here. So we'll get 170. A sub 4, again, we're starting with our initial term and throwing in 3 of those 110s. So that's a negative 330 plus 390, and that gives us 60. A sub 5, same game, 390 plus 4 of those, because the first one did not have a 110. The first one is the first term. Each subsequent one will throw in an additional negative 110. So this is negative 440 plus 390, which is just 60 minus 110. And then finally 390 plus 5 times negative 110, which will give us a negative 160. Okay, when you go to do your work on my math lab and on the test, you won't have to develop this. You just need to subtract 110 each time, that's all. The formula, though, here, it will be the same. Any of these terms or any further subsequent terms, anything in this sequence, anything in any arithmetic sequence, is going to be the first term, start with the first term, and then each time for any of the nth terms, we're going to subtract out a 110 based on n minus 1. No, Chloe. You'll be using this formula. Or you don't even use the formula. You just subtract 110 each time. On something as basic as this, I wouldn't expect to see any of this. I would expect to see like 300, like if I gave you this problem, I'd expect to see 300, 360, 420, 480, 540, 600, and that'd be your answer, that kind of thing. I wouldn't expect, and truth, in a multiple choice test, you wouldn't even have to show me this, because you'll just be matching to it. So this would certainly be work where you wouldn't need to show any work, a problem where you wouldn't need to show any work, because you could just compare the multiple choice and find the one you want. No, I'm just working through this so that you can see this. If I just handed you this, and that needs to be a D right there instead of a negative 110, because in this case, it is just the D, or it's negative 110. So the general formula would look like this: a sub 1 plus n minus 1 times D, and in this case, it happened to be a negative 110. So just like up here, this is the formula. The common difference happened to be a negative 110 in this problem. So won't use that one so much, this one. Where you'll use this is coming up in number 3 that we're going to look at. You will need to memorize this formula, because if I had asked you in this problem for a sub 412th, the 412th term, you don't want to take it out that far. You want to use the handy dandy formula. So we're going to use it, and you will need to memorize it. We have two formulas here. One is this one. You'll have to memorize that one. The other one is summing up all these numbers, and you will not need to do that because we're only doing that once. So if I ask you to do it, I don't think I do ask you to do it, but if I do ask you to do it, I'll put the formula on the test. This one, though, you need to know. We've done it in 8.1 a little bit and doing it now. Okay, let's see. Let's look at the next problem. Next problem is find a sub 6, the sixth term, when a sub 1 equals 15 and the common difference is 8. Okay, so let's use this formula rather than writing out the steps. Let's just jump in with the formula. So let's see, if the formula is a sub n equals a sub 1 plus n minus 1 times d, we're looking for a sub 6, the sixth term in this series. A sub 1 is 15, and the n that we're looking for is 6, so we'll put 6 minus 1 there, and the difference between each set of terms, each subsequent term is 8. So there it is filled out, and this is the case, Chloe, where, yes, this part will be 5 right here, yes. This is a good case where I would expect you, where I would require you to show me this formula worked out here. So if you're finding a sub 6, and I'll talk about this when we do the review also. And in your instructions, I'll say use the formula, must show work, something like that. Okay, so 6 minus 1 is 5 because we're looking for the previous term. We're adding into the previous term. So a sub 6 equals 15. 5 times 8 is 40, so we're getting 55 there. So the sixth term would be 55. Now, the sixth term isn't that big a deal. A sub 1 equals 15. A sub 2, let's add 8 to it. That's the common difference, so we get 23. Add 8, add 8, add 8, and then finally add 8. So we would get there pretty quickly. It wouldn't take a long time. But I will ask you to use the formula on the one I want you to use the formula on. And you're welcome to do it either way, but you need practice using the formula. Okay, let's go the other way. Let me give you a sequence. I'll give you this, and then we will work on coming up with the formula, plugging it in and doing it the way my math lab wants us to do it here. So we're still just looking at a series of numbers where a number has been added in. That's what all of this section is. So let's see, the instructions will say write a formula for the general term that's the nth term. That means we'll start out a sub n equals of the sequence. Sequence, remember, is just a set of numbers that something is added to the previous one. Then find a, then find the 15th term, a sub 15. Okay, let's look at 5, 12, 19, 26, 33. Okay, let's grab that formula back. That formula was a sub n equals a sub 1 plus n minus 1 times the common difference. So we're looking for what a sub n is. We're looking for a general formula for this series of numbers. So we're going to plug in what we can and then finish it up a little bit, and then we'll find a sub 15. So let's plug in what we do know. We've got a sub n equals, we know what a sub 1 is. The first term is a 5, And then n minus 1, we're going to leave that alone because we're looking for the general formula. We don't know which one they're looking for here. We do know the difference, though. The difference between each one. What are they adding in here? And I'm hoping that you can see that they're adding in 7 each time. So we've got a 7 there. This is good enough, but that's not going to match to what my math lab shows you. They want you to combine like terms. They want you to distribute and combine like terms. So let's do a little bit of that to neat this up. Notice that what we had to find was a sub 1 and the difference. Just like on the previous two problems, or the first two problems, they gave you a sub 1 and the difference. Those are the two crucial pieces of information. So we've got a sub 1, it was 5, and the difference was 7, and we're good to go. Okay, let's distribute this 7 and then combine some like terms. So a sub n equals 5 plus 7n minus 7. And then we've got these two like terms here. So a sub n equals 7n minus 2. And this is what will match to my math lab. That's what you're looking for. They want you to distribute this and combine like terms. So write a formula for the general term of this sequence. This is the formula for the general term of the sequence. We've taken it from here and kneaded it up a little bit, that's all. And now they asked us to find a sub 15. You could go back up in here and do 5 plus 14 times 7, but you've made it a little bit easier. So either way, 7 times n is 15, minus 2. So 7 times 15, that's 35, carry the 3, that's 105, minus 2, that's 103. So a sub 15, the 15th term in this series is 103. So they'll give you the series. You've got to come up with the first term. That's just the first term. There's no mystery there. And then what the difference is. And that'll be consistent. They're not going to give you anything wacky. They're not going to give you, I mean, these can be way, way more incredibly fun than this. But we're just, I mean, we're almost done with this section right now. We're almost done with the chapter. So we're just barely getting our toes wet on this kind of topic. Let's do another one like this. Here, let's find the general term, find the formula for the general, find the formula for the general term. And then let's find a sub 20 this time. Okay, the numbers, let's look at 12, 7, 2, negative 3. All right, let's see. If we're going to find our general term, we need to start with this guy, a sub n equals a sub 1. So you'll use this formula a lot. This formula will not be foreign to you by the time you have to worry about it on a test next week. In order to produce this, to fill this out and get the formula for this particular set of numbers, you'll need a sub 1, and you will need the difference between each two. So a sub 1 is 12, no mystery there. And then you need to see what's happening each time. It'll be consistent. If it's happening here, it'll be happening there. So we're subtracting 5 each time. That's a minus 5. Be careful of that. You're not adding 5, you're subtracting 5. So let's plug this into this general formula. A sub n equals a sub 1 is 12 plus n minus 1. That will depend on what n we're looking for, so we won't change that. Times, and then I'm going to be careful here. That looks like I'm subtracting 5. I'm multiplying here, so I want to put it in parentheses. They will, for sure, although they won't, because although this is a good formula, they want you to take it 1 or 2 steps further. They want you to clean it up a bit. So let's distribute. 12, and then that's a negative 5n. And then negative 1 times negative 5 is a plus 5. Let's continue to clean it up. So we've got a 12 and a 5 there. So you can either say negative 5n plus 17, or if you're kind of averse to putting the negative in front, you can say 17 minus 5n. It doesn't matter. I think I'll put the variable first this time. So negative 5n plus 17. This is what my math lab is looking for from you, right there. A cleaned up version of the plugged in version. And then let's find a sub 20. And we could go through and we could go, there's a sub 1, a sub 2, a sub 3, a sub 4. We could continue a sub 5, a sub 6, a sub 7, et cetera, until we got to a sub 20, the 20th term. That'd take a while. Let's use the formula instead. Negative 5 times n is 20. We're looking for the 20th term, plus 17. That gives us a negative 100 plus 17, which gives us a negative 83. So your two answers here would be this general formula kind of cleaned up, and then a sub 20. Oh, sorry, negative 83 for a sub 20. Okay. I think that we are ready to go to our last problem here. This last problem is a weird problem. Wouldn't it be 20 minus 1? Let's see. If you are writing it, we took care of that. We've got the n minus 1 right here. So that was a negative 5n plus 5. So that n minus 1 concept has gotten absorbed. And this is asking you for n, not for n minus 1. If it were asking you for n minus 1, it would say it. So when it says n, you're putting in this number. If it said, like right up here, we could go up here and we could do it. This would be 20 minus 1 right there. That'd be 19. That'd give us a negative 95 plus 12, and that would give us negative 83. Here it's got the minus 1, but it got absorbed when you multiplied it times negative 5. So if it says n, you're just using this number. You sure? I mean, I hear you saying okay. Are you lying? I mean, what, you're lying? Okay, okay. I just want to be sure. I could tell by your face, but I can't see your face. Good, okay, good deal. Yeah, if it says n, don't do anything fancy to it. Just accept it. It got absorbed in there. Okay, this last problem is a weird problem. Let me first get attendance here. Okay, got that taken care of. Let me explain it to you. Okay, let's start with what a degree day is. A degree day is a unit used in business to measure the fuel requirements of buildings. So a degree day measures how much heat you need in this case. How much heat the building needs for the day. By definition, each degree that the average daily temperature is below 65 degrees is 1 degree day. Okay, so each degree that the average temperature is below 65 degrees is called, is one, I'm going to write that out, is 1 degree day. For example, if it's 46 degrees on average today, that equals 19 degree days, because 65 minus 46 equals 19. So it's how much, it's a measure of how much heat you're going to need to heat the building. So 46 degrees would constitute a 19 degree day. The heat capacity is going to have to perform for 19 degree days. And of course, if it was warm, if it was like a 64 degree day, then 65 minus 64, that's just a 1 degree day. That's not that's not going to require much of the heating system. Okay, let's say that the average temperature on January 1st was this 46 degrees, and it fell 3 degrees for each subsequent day, up to and including January 7th. How many degree days are included from January 1st through January 7th? Okay, let's look at what we're going to need to do here. We've got formulas for this, but I want to show you how it works. Then we'll use the formula. You will not have to memorize this particular formula. It's a bit of a mess. And we're only using it once. That's the biggest reason. It's not beyond your capabilities. In fact, I think it's a little bit easier than the other formula. So let's talk about what we're talking about. We've got 7 days we've got to worry about. January 1 through January 7. Okay, they're telling us that it is 46 degrees on January 1st. It's going to fall 3 degrees for each day subsequent to that. So January 2nd, the average temperature will be 43 degrees. Drop 3 degrees, drop 3 degrees. Keep dropping 3 degrees. Okay, starting to look like our February. So let's look at, okay, this is the average temperature for that day, Let's look at the degree days for each one, the degree days. So at 46, that's 65 minus 46, that gives us 19 of those degree days. We already talked about that up here. So January 1st will contribute 19 degree days to the worries of the people who are heating this building. January 2nd, 65 minus 43, that's going to contribute 22 degree days. You're not going to have to build this table. I just want you to see what's happening here. I want you to understand what we're talking about. January 3rd, it was 40 degrees. It was even colder. So how much capacity does the building need to have? 25 degree days. It's going to have to worry about a capacity of 25 degree days just for January 3rd. And you can see these are going up 3. As it gets colder, the heating capacity requires more work. So 65 minus 37, that's going to give us 28 of those degree days, etc. 65 minus 34, it's going to be 31 of them little suckers. We've got 34 of them, and then we've got 37 of those degree days. Okay, the question here is asking us how many degree days are included from January 1st through January 7th. They want us to add those together. They want to know what is the total requirement for the building during those 7 days. So you would take your calculator And you just add them up. 19 plus 22, 25, 28, 31, 34, 37. Getting 196 degree days that you're going to have to heat that building worth of 196 worth of heat. Okay. There's an easier way to do this. There's a much easier way to do this. Let's look at how to do that in an easier fashion. What we're going to do here is we are going to use a new formula. The sum of n, and this will be 7 days, the sum of 7 days, equals n over 2, that's going to be 7 over 2 in this case, times a sub 1. We know what a sub 1, it's 19 degree days, plus a sub n, that's the 7th day. Okay, let's see what we can do here. We already know the answer is 196. We did that, we summed them up. We know that we're talking about 7 days. We know this variable is 7. We know a sub 1 is 19, and a sub 7 is 37. So we already have all of this because we built this table. But let's say we did not have any of that information, or we didn't have the table built out. How are we going to do this? Okay, let's look at how we're going to do it. We're looking for the sum of 7 of these. This formula will allow you not to build this chart out. So we're going to have n over 2, n is 7, parenthesis a sub 1, that was 46 degrees, so it's 19 degree days, so that's going to be a 19 there. We had that, we would know that. We would have to figure that out because they would tell us if we didn't have any of this. They're telling us that it was 46 degrees. They've already given us all this information, so we know 19 is our magic number for a sub 1. We would not know what our magic number was for a sub n, but we can figure that out. So let's go over here and figure out a sub n. A sub n, remember, that's a formula we've used before. A sub 1 plus n minus 1 times d. So we're looking for the 7th one. A sub 7 equals a sub 1 is 19 plus 7 minus 1 times, and then we're talking about how many degree days are we adding each time. They're telling us, and this is where you got to be careful, they're telling us that it fell 3 degrees for each day. That sounds like -3, and it certainly is. The temperature is dropping, but the degree days are being thrown in there. If the temperature drops 3 degrees, you're going to have to add in 3 degree days. So this will be a +3 there. As it gets colder, the requirements on the heat system increases. So that'll be a positive number there. So we can change that to a 6. So we get 19 plus 18. So we get 37, which we knew by building the table, but we're trying to avoid building this table. So here's the formula. We're trying to find the sum of all 7 of them, which we already know because we built this silly table. 7 over 2, a sub 1, that's just on January 1st, how many degree days would we have? And then on January 7th, how many degree days did we have? We've got the formula for that. So we figure that's a 37. So sum of 7 of them, 7 over 2, 19 plus 37 is 56. And then we've got, well, you can use your calculator, but 2 will go into 56 28 times, and 28 times 7 is 196. Let me show you that. I can find my silly calculator. There it is. So we're doing 7 ABC2, 7 ABC2 equals times 56. Let me see if I can do it without equaling. Does it know it's a fraction? I'm worried that it thinks I want to just multiply the denominator. No, it's fine. So 7 over 2 times 56, which is what this says, equals 196. So the sum of the first 7 days of the year of their degree days is 196 degree days. Okay, so this is the formula you'll be using. You won't have to worry about it on a test. I'll give it to you if I'm going to ask you for it. I just thought this problem with these degree days was a little counterintuitive because as it gets colder, as the temperature falls, you're adding in degree days. And so I wanted to look at that with you. Okay, we are done, ladies and gentlemen. So 8.2 done. It's 5 simple, dimple little problems. We will hit 8.3 on Monday, and on Wednesday we'll do the review. If you have any questions, stick around. Otherwise, I will see you on Monday, and I will hang out until the last of you leaves. Have a good weekend. You're welcome, Chloe. See you next time. You too, Ashish. Can you hear me now, Christine? Okay, you want me to go back over that last part with you? Would that be helpful? Okay, can you figure out where I dropped out for you? You can open your mic if you'd like to, if you want to. Okay, I'm assuming you just mean in this formula. I'll go over this.
Yes,
Oh,
ma'am.
good. Okay. So this S stands for sum. So we're going to sum up the 7 degree days that we've got here without doing this chart. So if you're talking about 7 terms, you'd put 7 over 2. It's asking you for the first term, and they'll give it to you up here. They'll talk to you about how 46 degrees is 19 degree days, and they'll show you that they've subtracted. So they get 19. So you use 19 for your first one. And then you've got to come up with this one, a sub 7, the 7th term. I did it out here, but I don't want you to have to do that. I want you to be able to use your formula. So a sub 7 is the first one plus 6 times the increase. It says it fell 3 degrees and the temperature is falling. You can see that. But we're not talking about what the temperature is. We're talking about the degree days, and those are rising because as it gets colder, the building has to heat harder. So you'll use a positive 3 right there. So 6 times 3 is 18. You get 37 for that number right there. And then it's just a matter of sticking it in the formula. Add those, multiply times 7/2, and you get 196 degree days. That saves you, this formula saves you from having to do this, and you get more practice on this formula. So does that cover what you missed, do you think? Okay. Good.
Yes, ma'am. Thank you so much.
So
I'm
welcome.
sorry about that.
Bye-bye.
I apologize.
Say it again.
I'm sorry about the sound. I apologize. I do apologize.
Oh, don't worry about it. Oh, my goodness, Christine. That happens. That's the way it is until maybe the fall. And I hope we don't have to worry about this again. So no problem at all.